we welcome you all to this IITPSA DevOps User Group joint webinar. I'd like to welcome Candice Mesk from the DevOps User Group and Dr. Gordon Ings from the City of Cape Town, and I'll leave it up to Candice and Gordon to carry us forward in a moment or two. Just to point out, from the Institute of IT Professionals, we do welcome you. And as some of you will know, we have recently launched an Ethics in IT video, which we do like to present at the start of each of our webinars in which we are involved, just so that everybody is on the same page with regard to ethics. So I'm going to start that now, and then we'll get into the meat of the webinar. Sit back, enjoy, and we'll catch up with you shortly.
As professionals in the world of information technology, we use our creativity, skills, and understanding of the world around us to make change. Each piece of code, technology, or information that we send out into the world takes on a life that has the potential to change the world around it. In our fast-paced world of AI, robotics, media, and communications, the actions we take dictate the future of these technologies. These technologies significantly impact people and the environment around us. As we grow, understand, and adopt AI both in our work and personal lives, we will be presented with moral and pragmatic decisions that can be used either in the upliftment or to the detriment of those around us. In everything we do, it is important to visualize, study, and calculate the impact that our creations will have. The fundamental way to achieve this is by imagining the impact your actions could have on you, your family, community, and society. Personal information can be readily stolen through phishing, viruses, and malware, leading to psychological, social, and financial harm to individuals. This abuse of personal information poses a threat not only to the affected individuals, but also to organizations at large. Imagine if this happened to you or your loved ones. We often underestimate the significance of our work, yet it's crucial to recognize that we are at the forefront of innovation. We play a pivotal role in propelling our world forward and shaping the future. We have the ability to mold our future into one that is filled with darkness, destruction, inequality, and unsustainability. It doesn't have to be this way, though. By using our skills, tools, and insights into the impacts our actions have on the world around us, we can build the future into something beautiful and exciting. A future that does not only benefit us, but benefits society and the generations that will come after us. We as information technology professionals can do this by always considering the ethical impacts of our actions. If you work in the ICT sector in South Africa, consider joining thousands of IT professionals committed to developing their unique skills across various sectors, all working towards building a stronger and more sustainable future for the greater good. To apply for membership with IITPSA, visit www.iitpsa.org.za.
Awesome. So thanks everybody for listening and watching that video. And I'm going to hand over to Candice to take us forward. Thank you, Candice.
Thank you, Tony. And a special thanks to the Institute for inviting us to present today. Well, I say us, but Gordon over here is doing all the hard work. Welcome, everybody. My name is Candice Mesk. I belong to an organization called the DeveloperUser Group, and we are the non-profit organization that runs DevConf annually. Last year, I had the privilege of meeting Dr. Gordon Ings at a data conference called DataConf, where he presented a very interesting talk about some of the work that he does at the City of Cape Town. And today I am very privileged to be able to introduce him to all of you. So thank you, Gordon, for joining us. You will be telling us about Wrangling Table Mountain or something about ELTs and ETLs. And I'm sure we're in for a treat. So over to you.
That's great. Thanks, Candice. If you don't mind, do you mind just indicating that my audio is still coming through fine?
Yes, audio is perfect. Are you presenting yet?
I'm just firing it up on my side. This is the technical trouble we were having before, so please let me know if my if there's any problem with it coming. Okay, everyone see my screen okay?
Yes,
fantastic.
Perfect. I'll be keeping an eye on the chat for questions, and then when we get to the end, I'll just read them out to you.
Sure, yeah, and again, just good afternoon to everyone. I appreciate that it's probably pretty hard to tear yourself away from your favorite election results dashboard, but hopefully I'm going to be sharing some data content with you that will be equally interesting. I'm going to try and talk for about half an hour, and then leave plenty of time for questions and discussion. Certainly, the way what I get out of these sorts of talks and presentations is always the input from the audience. That there's always great discussion that happens afterwards, and so I want to maximize that for my own selfish reasons. So just to start the talk, I'm talking about our journey from ETL to ELT, which those of you in the data space have probably heard something about. I'm trying to be very, I'm making very few assumptions about what everyone knows, and if you know far more about this than what I'm talking about at the moment, please feel free to let your attention wander. So I'm a principal data engineer at the city of Cape Town, and I'm going to be telling you a little bit more about who I am and my background. And then I'm going to launch into, really what I think is the sort of elevator pitch for data engineering. Why does it matter? Why is it a profession that's sort of really emerging out of the shadows a little bit behind data science? And then I'm going to launch straight into, probably what is the primary construct in data engineering, which is the data pipeline. A little bit about what that is. I take a very general view of what a data pipeline is. But the reason that's obviously relevant is because it relates to, the primary focus, which is the extract, transform, load versus the extract, load, transform pattern that is the focus of what I'm going to be saying today, which is really just two different ways of thinking about how you organize a data pipeline and what a data pipeline does. Then I'm going to launch into the bit, which I think is sort of going to be a little bit different from every other data talk you'll hear. And then I'm going to be talking about data engineering at the city of Cape Town. And that worked example I'm going to be talking to relates to something called a service request, or a C3, which, if you live in Cape Town and you've ever asked the municipality to do something, you've probably created one. But I'm going to talk a little bit about some work that we did in this space. First, following this ETL paradigm, and then secondly, some more work which actually arose out of the first work, but that follows much more this ELT paradigm. And I'm hoping you sort of using those two devices, I can talk through something that makes sense. And then I'm just going to close off, share some of my opinions unbidded. So very quickly about who I am. I'm a native Cape Townian. I actually grew up in Simonstown amongst the Penguins. I studied at UCT, doing my undergrad and master's, focusing in electrical engineering and computer engineering, which is this very common program these days, which is sort of a mixture of computer science and light current electrical engineering. And then I went overseas to do my PhD in computer engineering at this university called Imperial College London. It's a very science and technology focused institution. It's technically very brilliant, but tends to sort of hide from the headlines a little bit. And then from when I finished up in London, I got a bit homesick and I wanted to come back. And I really wanted some industrial experience too. So I went to work at Amazon Web Services at the engineering center in Cape Town, and I, in particular, worked on the EC2 product. So again, if you ran a virtual machine from AWS between 2016 to 2018, there's not a unreasonable chance that at least it was running on some of the code that I wrote. But then in August 2018, this opportunity came up to join the city actually as its second data scientist. And that was very exciting. And I spent a couple of years working as a data scientist. But by 2021, I realized that actually what I was spending most of my time doing was this thing called data engineering. And that very nicely leads into my next slide about why you should care about data engineering. So if you talk to people and sort of consultants and things, what they will, I'm just going to tweak the zoom of this a little bit. It seems to be doing something a little funny. There we go. They'll say stuff like this: data is the new oil, and it's this pathway to become very rich and powerful and important. And to be honest, that's not the sort of thing that motivates me, or I'd like to think so. Actually looking at surveys of millennial and Generation Z workers, that actually doesn't really appeal to them too. I think the sales pitch which really appeals, and I apologize, but this is sort of a messy visualization on purpose. This is a table reflecting some information about residents in the city of Cape Town who are ratepayers, who owe the city money. And what you can see in this first column over here is the proportion who fall into different groups. I've deliberately obscured a column here, which is about the property band that they fall into, the value of their property, because in the municipal context, we levy property taxes on the basis of the value of a property. And looking at the data, what we saw was that there was a particular group who were sitting just above what was a support threshold, where we give significant rates, rebates, and free services to people. And we saw something like 20% of the municipal debt was sitting inside this group, despite their property value being way below the property values that we see at the higher echelons. And this was obviously very concerning. Another thing that was very significant was we saw that it wasn't actually the property taxes, the rates that was costing a lot of money. It was the services that these households were using. And so they were in desperate need of some support and help. And what, I was working with a large number of colleagues in the revenue department, as well as our valuations department, as well as our strategic planning. So it's a very wide group of people. And what we did is we put this together. And, you might say, well, yeah, so what? This is the sort of table that I can draw in Excel. But there was something like 3 billion data points that went into creating this table. And the reason for that is that debt data is actually quite complex. And especially if you want to look at it at the level of granularity that allow you to roll it up in these sorts of interesting ways. And so in terms of why does data engineering matter? To me, it gives your organization the capabilities to, look at its data in any way that it chooses. And, data like this has been available to the city of Cape Town for a long time, but the ability to process, those 3 billion data events into a form that allowed them to then make a decision, or, make a very easy decision, because it was very, very easy to take this table to senior leadership to say, look, we need to increase our support threshold. And so, this is why I think data engineering is really this field, that in parallel with data science, or a little bit lagging, a little bit behind data science, where people have really woken up to these amazing insights that they can derive from the huge amounts of data that are being generated these days. But you really need the capability to actually get that data in a form ready for use. And that very nicely leads me on to my next slide about what is a data pipeline? And, this is the central construct that we're going to be talking about. And, when I'm talking about these different architectural patterns for them, what is this thing that, it's really the primary artifact of data engineering, in my view. It's the thing that, you build on a regular basis. And I actually define it in quite a very glib way, which is to simply say a data pipeline is something that gets data to where it needs to be. But there's a lot in that, right? In that, firstly, it's something that might be happening on an ongoing basis, as the sort of word pipeline suggests, or it might be something that's event triggered. So say, for example, some new record is created in a system somewhere that might trigger then some additional processing. Another key feature is about automation. And as much as is possible, a data pipeline and the work of data engineers is about automating the flow of data from from where it comes from to where it needs to be. And that's something that really differentiates, I think, data engineering from a lot of the workflows. And certainly what we see inside large bureaucratic organizations is often a very manual reporting workflow that has lots of people involved in it. And sure, when a person needs to exercise judgment and make decisions and make calls, it's entirely appropriate that they're involved. But it is really not good and dignified work for someone to, download a spreadsheet from somewhere, build a pivot table out of that spreadsheet, and then email that spreadsheet to someone else. Like that's not there's so many other things that person could probably be doing with their time that would be so much more value adding. And so data pipelines are these things that, largely should be a collection of software and hardware that allows for the flow of data to be automated. And I think this is the final point. And I think this is quite a subtle one and sort of gets to a lot of the heart of the ETL stuff versus the ELT stuff, is that a data pipeline prepares data for analytic use. And that it's one thing about getting data, as I said, it's a bit glib saying like, we just need to take data from one place and make it appear in another place. But anyone who's done that sort of work knows that there's a huge amount of practical considerations. It's really an integration problem, going from something that is, say, for example, a raw record of an interaction with a resident to something that is something that can be used in an actual analytic workflow, something that's nicely structured, something that maps nicely into a BI tool or a fourth generation programming language like R or Python or something like that. There's often significant things that have to happen between the creation of the data and that happening. And that's very much what I'm going to be talking about now when I start talking about the ELT versus the ETL pattern. And I must give credit to this. My attribution has disappeared, but this is a great diagram that I found online that gives you a really nice overview of these two patterns. And actually the ideas behind them are really simple and straightforward, and I'm going to explain them in a bit more detail. But really, what we have on the left there is ETL, which is this notion of you get the data from somewhere, then you have your transformation in the middle, where something is done to that information, and then the load, which is essentially putting that data somewhere so that it can be available for further use. And I'm pretty opinionated that a data pipeline is primarily about making that data available for some sort of analytic use case. Whereas the ELT pattern, it's a little bit more mysterious, and it seems to be a bit more streamlined in that what you do is you extract the data, and then almost straight away you load it and then make it available for some sort of transformation. And I'm going to sort of talk through a little bit more detail about each of those terms. I've largely already mentioned it. But I think maybe just the final point I'm going to add, because I've mentioned, what these things might be, is that often that extraction and transformation step is called ingestion. But what, I think maybe what would be helpful in terms of understanding these things is, if we think about, extract the different types of extraction that you can maybe have. The very obvious one is, for example, if you have a large transactional system, maybe it's your, place like the city, it might be something like the system which has all of our maintenance information, there's all of the work that's done on our various assets. And that system as a component of it typically has a database that's very optimized for transactional use. It's planning on having multiple TPS, probably, people doing things inside that system all of the time. Probably doesn't care a huge amount about data provenance, as long as the information that's being reflected in the system is faithful in terms of the transactions that have preceded it, right? And so, that's sort of one category of extraction that would be pretty common. But another category, and there's all sorts of exciting emerging use cases, is, for example, data coming in at a high velocity from something like a sensor network that you might have out in the field. Or, again, to use an example from the city, something like all the information flowing from our traffic lights. And in that instance, typically then you're not acquiring data from a structured database necessarily, although sometimes systems like that do put their data in a nice database, which you can go and query. Often then you're consuming it from some sort of streaming, usually a queue is the sort of paradigmatic, the data structure thing that you're going to be interacting with, right? You then do a transformation on the data, and I think I talk a bit more about the transformations in a second. So I'm going to, oh no, took that slide out. So let me talk a bit more about transformation here. But here, there's a couple of different things that can happen. Probably what's most important to be thinking about is sort of often what I would call like a linear transformation or a sort of non-destructive transformation versus a destructive one. In that, for example, taking data that is in a particular format and coercing it into another format, provided you're not throwing away information in doing that. So you have a string which represents a date time and you turn it into a proper date time, format, something that's hopefully nicely ISO 8601 compliant. That is a non-destructive transformation. You're not throwing away any information there. Probably the most common form of transformations where you are throwing information away would be some sort of aggregation. And this will sort of give you an early feel for why the shift from the one paradigm to the other is that, the moment you start aggregating information together, you're essentially transforming multiple observations in the data into a single observation. And it might be that no one minds. Say you are adding up all of the maintenance job that a particular crew has done in a particular day. So you have a simple count of the number of jobs done per day, as opposed to a record for each job in your data set. But in other cases, you might want to say, do some statistical analysis of the distribution of effort across the different jobs. If you have that aggregation, unless that aggregation has been done in such a way that allows for the particular type of statistical calculation you want to do, very often it becomes quite difficult to then do that analysis. And then finally, there's the load. And again, I think that there's a lot that can be said here in that, primarily what you're doing is you're making the data available so that it can be used somewhere else. And for an analytic purpose, and in a rather opinionated way, I tend to not view visualization as anything too special. Very often, either you have a platform which can do visualization trivially off the information that's been loaded somewhere, or you can just view visualization as another form of transformation, and the load is something that's happening where some platform is making that visualization available to someone. But this is maybe something we can get into in the questions and answer section. It's sort of one of my more controversial data opinions, it seems. But these are the things that these are the three types of activities that we do. And obviously, as the paradigm name suggests, what we're wanting to do is do them in slightly different orders. But before we do that, I just want to talk a little bit about sort of storage paradigms. And, I think what's interesting here is that very often discussions in data engineering or discussions around the use of data in analytic spaces devolve into discussions about your data storage technology and how your data storage technology is conceived. And that's a very important consideration. You definitely need a storage technology that is appropriate to what you're using it for. But I don't think it's the be-all and end-all of being able to do good analytic work. And to be honest, focusing overly on the particular system or set of systems that you're using in this space often then distracts from what other people are looking at, or other things that you need to think through. For example, how your data pipeline that populates things in these different storage technologies, or takes stuff out, does some more processing and puts them back in, is conceived and structured. Too often, I've come across a couple of examples where people seem very happy to pay huge amounts of money for a cloud data warehouse, but then not see fit to give their analysts anything better than sort of a commodity laptop to process huge amounts of data. And I think that there's a lot to be. There's a lot of discussion around storage paradigms, and maybe we can go in the comments talking a bit about data warehouse versus data lake versus the new exciting combination of the two, which is a data lake house. And I must be honest, we actually use this setup in our environment in the city of Cape Town. But I would say that these things are all elements and components often of your data plane, which is orthogonal to your control plane, which is the orchestration and organization of your data processing for analytic reasons, right? So just to finish off this bit of the discussion before I sort of get into the worked examples, just in terms of there's an important historical context in terms of ETL versus ELT, in that ETL has been around for decades. 1980s to 2000s, sort of longer than I've been alive. And this, it's actually quite interesting to think through, sort of its emergence in relation to large relational databases becoming available to a wider and wider number of organizations. And, something that I think is very true of a relational database is that it's actually also a very natural platform upon which people can do parallel programming, which is actually quite a difficult thing to do right. And for a long time, a lot of people didn't really have to think about parallel programming because everyone had only single core processors available. But if you're writing queries against the database that, you're not thinking about how your program is running, you're just running a query against the DB. And that gave these relational databases actually tremendous scope to do a lot of parallel processing. But in conjunction with this, to make effective use of this idea of ETL and large batch jobs that would run periodically and take data from one form, do some sort of transformation, often a destructive transformation, and they would aggregate it up and they would make it available. A sort of refinement that emerged more in the 90s, although it was, I think, started in the late 80s, was the notion of an OLAP cube. So it's an idea of like a partial aggregation where you only aggregated on certain dimensions, but you largely left the cardinality of those dimensions intact. And the value of doing that was obviously then you could, you had some ability to still slice and dice, but it was quite limited. And, the moment your question, very often you'd have a set of questions which would require you to go back to the underlying source data. Then in the 2010s, we had the emergence of the cloud data warehouse, largely, with the emergence of cloud computing in general. And in combination with that was this notion of starting to use columnar storage. So rather than storing everything row by row, you would store things in columns. And that gave you all sorts of advantages. Largely it gave the cloud implementers lots of scope. And it also, I think, very important was it enabled scaling in a significant way. And it's no coincidence that this was happening in conjunction with the emergence of technologies like social media, which were generating huge amounts of data, right? We just needed better ways of processing things. And if you're trying to process, hundreds of millions, if not billions, of records using a relational DB, you would often struggle, and it would be you would tie yourself in knots trying to shard that data across many servers and things. And that brings us today, where we sit with this often what people call the modern data stack, which is often this abstraction of many paradigms and technologies running underneath the hood, with something like SQL acting as like a lingua franca that's used between these things. So that's sort of when it's in the 2010s and the 2020s where the ELT paradigm has started making more and more sense, just because why aggregate prematurely? Why not leave that to the user to do on the fly as needed? And that's what I'm going to really hopefully illustrate with my example of the service requests in C3s, and show you how we went from the one use case to the other. So our sort of evolution, in a very sped up way, we followed the evolution of everyone else over the last few decades. So a service request or a C3 is, as I mentioned earlier, something when service delivery goes wrong. And it's also, it's when something has happened that requires, you want the municipality to address it. So a blocked sewer, or the power supply to your house has stopped working, or there's a pothole in your road, or there's a verge that needs to be cut. It's real bread and butter stuff, and actually one of the best features of this from an analytic point of view and from a data set is it's a really good proxy for when things aren't going right from a service delivery point of view. It's a really useful thing to look at to tell you something about, it's a set of problems. If you're thinking of like a ticketing system or an issue tracker or something like that, it's basically that on like a citywide scale. And there's lots, it's very fruitful. And the city of Cape Town generates something like 1 million. I think we're probably going to hit 1.2 million this year of these service requests. So it's not an insignificant number. It's a large. It's a sort of probably not even medium data yet. Still small data, but it's a big enough data set that you have to think things through if you're going to sort of extract meaning from it. And just the final point is that I think it really goes to the constitutional mission of the city, in the sense that if you read Chapter 8 of the Constitution, which relates to local governments, it largely speaks about the things that service requests are concerned with, the sort of provision of fundamental basic services that everyone needs on a day-to-day basis. This is a little snippet of what one of those data sets looks like. It's a little bit cut off here, but you can see there's an identifier of some sort, there's a timestamp, there's a organizational there's an organizational attributes, and then there's actually, this is the bit that's cut off on the right, is the code, which is the categorization of the different issues. I'm first going to talk about the ETL example, where we were involved in a project, and this started in late 2018, early 2019, where we wanted to rewrite one of our performance indicators, which essentially there was a citywide performance indicator for completing these service requests. And if you look at the heterogeneity of the work that goes into them, like filling a pothole is very different from fixing a blocked sewer, is very different from a burst pipe, is very different from, large scale power outage. And so these things needed different targets based upon those types. But then obviously we needed to compute a proportion of those things that were completed within their target. And so we, as part of our role in this project, was we were building a tool that would help people preview the service standard at these different levels. And you can see we built a little tool that looks like this, which starts off at like quite a high level. So this is the directorate level, which is like the highest organizational unit in the organization. And then within that, we have our departments. So I'm expanding in the video the community services and health directorates. And then inside there, one of the departments called recreation and parks. And then below that level, we have the individual request types along with the targets. And you can see, this is performance against those targets for various timeframes. So a very simple little web app that runs. And what why was this ETL? In the sense that Well, first we had to get the data for these service notifications that came from the Oracle database that sits underneath the city's SAP ERP system where these notifications live. And then in terms of the transformations we did a non-destructive a set of non-destructive transformations, a whole lot of quality of life stuff around cleaning up the data in an automated fashion. And this relates to type cohesion type stuff and inserting proper nulls in certain fields and combining dates and time fields to make timestamps, etc. Then there's another sort of non-destructive transformation, which is joining in the proposed targets for the different request types. So it's just a simple join. And then the final one, and this is the destructive transformation, is to roll up to the organizational level. And once we had done this, we transformed this, and this is the load step. We turned it into some JSON that we then loaded and made available to that tool. So that web app would run, and based upon the most recent information available to it, it would just, well, when someone loaded it up, it would just fetch the JSON, and it would be then available for use, it would reflect the current status of things. This application actually had a very curious life in that we expected it to last a good 6 months at most while we were setting these new targets and people were previewing things. And I actually only turned it off in mid-2022. And within turning it, disabling it, and we put up a little redirect notice saying that this is no longer being used, I received something like 4 emails within an hour from people who had somehow incorporated it into their workflow. And because it was hooked up to a data pipeline that was feeding in fresh data continuously, it was part of what they were doing. So obviously we had conversations with them, and we helped them out with some new tooling that does that, because we really didn't want to keep maintaining that thing. But yeah, it just goes to show you too that the power of automation, in that even very sort of throwaway things that you think won't hang around a long time, turns out that ongoing information is a pretty useful thing. So the next thing, which is the illustration of the ELT paradigm, is once we had people saw this thing, then they had these inevitable questions. They said, yeah, it's great that you have this information on like the department or the directorate level, but I want this for my branch or my unit or my depot. They wanted to go very specific. And sure, you can use some sort of like an OLAP cube type approach to try and do that. The city's org hierarchy doesn't change much, but it does mutate periodically. So we could coerce the data into, get it into that structure. But it would be quite a lot of processing work. And, the city has several thousand unique organizational units. And if only a handful or, tens or even hundreds of people are looking at those org units, that's a lot of wasted effort. Another question is to say, yeah, it's great to have this stuff at the citywide level, but what about my ward or my sub-council or my suburb or, the little, the few streets around my house? What about, what's going on there? And then, or they would come and they would, this was the sort of more advanced, this would be someone who would say, please tell me about all open notifications that have been open for longer than 3 weeks that are located in this suburb and, belong to one of the 5 following categories. These like really specific things, which again, you spend a bit of time thinking of some SQL and you can write it, but that's not very efficient. That involves, human in the loop. Often it involved us. And so, we then had, we sort of found a common pattern here, which was that we needed a drill down tool, something that allows people to filter on a sort of ad hoc basis as needed. And so what we did was, in that, if you remember in the previous paradigm, we extracted the data, we did a whole bunch of cleaning and then we started aggregating it up. We didn't do that. At the point where we joined in the targets, we then loaded it into an appropriate data storage technology, which in this case was Elasticsearch, for those who recognize the Kibana styling. And then we built basically, it's a dashboard inside Kibana, which is a BI tool that plays very nicely with Elasticsearch. And we built a tool, and you can see here that it has all of these filters available that allows users to go and select an arbitrary set of attributes that they care about, apply them, and have them applied to the data in near real time. And the data behind this system is something like, at this point, it's approaching 10 million observations, maybe 12 million observations. It's starting to get past the point, the sort of thing that you could process on a laptop comfortably. But I think what's important is that people just need to visit a web UI and they're able to get access to the latest information. And then based upon the filtering that they apply, they can then see the very, the exact combinations of things that they care about. That's pretty powerful. And this remains one of our more popular tools. It's something that we keep available to people, and it's been used in all sorts of different and interesting ways. And I think what's probably really enjoyable is how people, caring about all of the interesting use cases that people have for this. There's nothing more satisfying than building a tool and then hearing about a use for it that you never possibly conceived of. Okay, so the reason that this, as I mentioned before, is we did an extraction and we did retain some transformations. And this is actually a subtlety with ELT. A lot of people talk about small t LT, and they use the small t to indicate these non-destructive transformations. And this is actually something that we found very valuable with this data, is that we have done a lot of enhancement and enrichment of the data by joining in from all sorts of different places, as well as improving, for example, the geocoding on the notifications, because not all of the notifications are straight away created with their geo coordinates. Often they just have a string address associated with them, and I'm not going to go into the reasons why now. But we did a lot of that. We've been doing a lot of that, and we boost the geocoding proportion, which in turn allows for the data to be, used and surfaced more easily. And then I'm not going to talk about the loading because I already mentioned it. See, I'm on 35 minutes, so I'm keen to get to that discussion. Just to conclude, our view is that a data engineer works in very tight coupling with some sort of analytic function. And really the job of a data engineer is to enable the answering of analytic questions. And the best way to do that is by providing good data sets that are good for analytic purposes, and providing data, this artifact, the data pipeline that causes those data sets to come into existence and remain in existence. ETL and ELT are just ways of thinking about how you organize those data pipelines. I don't, by the way, think that ELT is the only thing you should ever do. I think there's still many cases where it's appropriate to do ETL and worth doing. And then finally, I think hopefully you got a taste of this from the example that I used, is that government is not known for being cutting edge from a technical point of view often. But we really, in our experience over the last few years, is that there really is a role for good data and analytic work to be done in government, and ultimately that feeds into better decision making inside government, and in particular in local governments, particularly in relation to operations. There's plenty of opportunity. So just to mention before I say thank you. Here's a couple of key sources. I always like to recommend books, and those who know the O'Reilly books will know what I mean about the animals on the front. But these are just a couple of books and articles that I found really helpful, informing in relation to this topic, and I think I would recommend. Thank you for listening. Really keen to hear any questions that you might have. And thanks a lot.
Thanks, Gordon. That went rather quickly, but I think there was a lot that went into preparing all of that. We have got a couple of questions in the chat. I have one from Kim asking about if end users need to use Kibana directly, or is that just a front end in front of relevant graphs, exploratory tools? Can you tell us about the customer's experience there?
Oh, yeah, it's an interesting question. And then look, I think one of the most interesting questions which organizations across the world are grappling with is self-service analytics, right? So should you to what degree should you be trying to put tools into people's hands and get them to be writing queries or creating graphs like a no-code way? Or to what degree should you be presenting like very opinionated and well-sculpted and views of the information that they can just look at and consume directly, or you even push to them through some channel? So in our particular example, in our case, the Kibana, that Kibana interface, we're sort of using it just as like a front-end technology, really. We've built a dashboard in there, but the users don't have edit permissions on that dashboard. So they can go into the dashboard and they can, there's some filter controls and things that they can use to modify what they see in it, but they can't fundamentally alter the structure of the dashboard. A few people have wandered over to the like custom visualization section of Kibana, and we don't tie that down. So people can create their own custom visualizations if they want. But generally speaking, we haven't had a lot of uptake of it. We haven't pushed it, but I would love to carry on talking about self-service analytics and BI tools and things. But I think I'll leave it there in terms of saying that, I think there's a lot of scope for both. I think that sometimes you're going to want a very polished, well put together view. Think of that like the dashboard on your car, the dials and indicators that everyone looks at, to sort of help them where they're going. And then BI tooling, that's, some way to slice and dice and do your own aggregations. I think generally the audience for that is often a lot smaller than people estimate, but we'll think about, but I think it does exist often.
Thank you. I hope that answers Kim's question. We've got another question from Tenzi asking about popular tools for ETL and ELT.
Okay, that's a great question. So, I think largely speaking, the thing I immediately think of then is data pipeline technologies and the things that you use to orchestrate your data pipelines. Internally, we make very heavy use of a product called Apache Airflow. And, again, you could do many, many talks on Apache Airflow and its uses and misuses. And there's sort of a whole family of very similar to, not very similar, but same sorts of ideas. There's Dagster, Prefect, Envoy to some degree. So that's in terms of like how you control and manage the dependencies and the relationships and the scheduling and the triggering of things inside your data pipelines. But then, there's obviously the technology that controls what happens inside your data pipeline and does the manipulation of actually does things to your data and does the extraction and transmission. And there's quite a few different approaches to that. Of course, you can use standard programming languages, things like, Scala via Spark, or, I haven't seen Hadoop around much these days, but, Hadoop is one of these these frameworks for doing that too. DBT is very popular right now, obviously. Internally, we actually use a lot of Python and R, and I actually need to do an update. A few years ago, we did a talk about how we run our data pipelines. I quite like I must admit, I like approaches that are very composable and allow you to pull out the individual elements and sort of run the different elements separately. So that's probably why we've done that. And then, of course, the other thing is obviously your data storage technologies. They're a big part of your data pipelines, and choosing the right technology for what you're doing or using a certain technology in a particular way is really important part of it. And there's obviously relational DBs, there's your NoSQL DBs, and then obviously object storage, and we use a lot of object storage, and that seems to be a very common pattern as part of the data pipeline. So as you're working through your data pipeline, results are being read from and written to in an intermediate form in your object storage. Yeah, okay, I don't want to go. Yeah, as I said, this could end up being a very long list. But I think again, there's a whole talk on. Oh wait, sorry. Maybe one final thing to mention in this regard is streaming technologies and the use of things like Kafka or simpler message queues. Those are another sort of important, and that gets a little bit fiddly sometimes because your control plane and your data plane are often very tightly coupled. But yeah, I hope that gives you a nice feel for some of the stuff out there.
Great answer there. So there was actually a follow-up question from Tenzi, but I want to give some of the other people a chance. So we have a question from Jason asking about sharing of data across departments and teams in your organization. Have you implemented any access control over that, or how's that working?
Yeah, that's a great question. So in terms of access control, and this is something that I can really encourage data teams as much as possible, make it someone else's problem. Most tools have good support.
Like whose, Gordon?
Sorry?
Whose problem should we make it?
Yeah, no, IT.
Yes.
Yeah. So at the city, we the team that runs our Microsoft Exchange servers. But obviously you need a way, you need a protocol. So getting familiar with OAuth, I would recommend if you're interested in making auth someone else's problem, use OAuth. But in terms of the permission management, I've been a little bit disappointed that largely speaking, it often ends up being something you do on the tool itself. Although we make use of a query engine called Trino, which is a fork of PrestoDB. And then, for our general BI tooling, we use a platform called Apache Superset. And what's great about both of those things is they do row-level permissions. And so through a combination of group membership and then, mapping those onto roles, and then roles having various levels of row-level permissions. And so, for example, we have a dashboard that contains HR information, and it's really awesome being able to just very liberally send out the link to that HR dashboard and know that the people accessing it, because of the authentication mapping them into the right part of the org hierarchy, they'll only see the HR information they're authorized to see, right? And I think that feels like a good pattern, but as I say, I don't love that that's all being managed inside either the end application superset or our query engine. I would much prefer that permission management living somewhere else too, but what you going to do?
That's insightful. Thank you. A question from Vishal. I think I know this, Vishal Gupta. Hello. Which crucial technical skills are needed for the data engineer role? I think that's a great question.
Ooh, yeah. We've done a lot of hiring in this space. So yeah, we could have so many opinions about this. Look, I think coming from a software engineering background is often very important, but and I think this is something sometimes that's quite difficult to find amongst people in software engineering. Is also someone with a bit of an analytic sensibility and a bit of stats knowledge. Because, when you're making judgment calls around the data transformations to do and deciding okay, we've accepted we have to do some sort of ETL, we're going to be aggregating across these dimensions, or, should we throw in another dimension, etc. I think that's getting that combination of software engineering along with, that sort of analytic insights. But to some degree, that can be mediated through cross-functional teams where you have data scientists or data analysts working very closely with your data engineers. Unfortunately, also because depending on the scale of the data sets you're working with too, it often requires knowledge of infrastructure orchestration and the ability to scale jobs and run distributed processing jobs and stuff like that. So someone with a bit of an HPC background is also something that we get excited when we see that on a CV. But yeah, I think that sort of, I think this is true of everyone who works in data, but I think sort of a high degree of curiosity is always something, someone who always asks, like, why is that? Or, why does that column look like that? Or, someone who's going to probe a bit, I think is also something that's, sort of on the other side, the non-technical side of things is also a sort of good attribute that we look around for.
Thanks for that. I see we're running really short on time. If I can squeeze one more question, would that be okay?
Yeah, that's fine for me.
Okay, great. The question is around open data. So it's from Carl asking, to what extent has the city embraced open data? Do you have a portal for users? I know you've spoken a bit about the Kibana one, but yeah, any thoughts there on open data?
Yeah, the city is actually a signatory to I think it's called the Cape Town Agreement.
Original.
And we have quite a full-featured open data portal. It's built on top of some software from a company called Esri. So that would, and they're a GIS. They focus in on GIS data. So, in fact, the data you're interacting with on our open data portal is comes from. Oh, whoops! Let me click on that link. Oh, there we go. Comes from our many clicks. That's coming right from our internal GIS systems, actually, and they're being mirrored out on a near real-time basis. So as the information is getting updated inside the city, they're getting updated on the open data portal pretty quickly. But some of the other data sets, there's other data sets which are non-spatial in nature. And so those ones, they get updated. There's a metadata there that'll tell you how frequently that they're updated. But yeah, we see open data as a really important. It's actually, the data that is produced by the city as part of the operations of the local government, we see as an asset that belongs to the residents of Cape Town. And as a result, we should be doing everything we can to put it in people's hands. Obviously, we want to do that responsibly, but as much as we can do it in a sort of quick way. And actually, this does give me an opportunity very quickly to plug a project that we have in the public domain, which would be, I'm sure there's some people on this call the seminar, that it would be really nice to, for you to maybe start making use of this. We have a public data API, which relates to service outages in the city. So, this is not at the notification or the request level. This is slightly higher level. This is like if water is off in your area or electricity is off in your area. It's pretty close to live, but sort of like with a few minutes delay. And yeah, we're putting this out there. Eskom's push is already making use of it, and we've got a few internal products that are using it too. But yeah, it will also be, this is another frontier in the open data story in terms of putting out sort of near real time information. And it would be really great if people could pick it up and play with it, and also feel free to go onto GitHub and comment on the spec and ask for features. This is something that we're quite excited about, and we think we're looking forward to. Hopefully getting some great use.
Very, very cool. If you've got a chance to pop that link onto the chat, I think it would be appreciated. I'm sure people will be interested in going to interact with that at some point, or contributing if it's open source. I'm not sure if it is.
Yeah.
Or it will be. Okay. Nice.
Yeah. It's all...
That's really cool. A comment from Earvault. It was a question, but I think it's a cheeky comment. He's hoping that at DataConf this year he's going to see a more in-depth version of this presentation.
I think I'm getting a bit close to the deadline there. I have been eyeing it. I want to go to DataConf and just listen to all the really great talks, and I hope Earbolt's going to do another one. I really enjoyed his one last year.
Earbolt has been banned from DataConf for throwing sweeties at the audience, but secretly we hope he'll be back. Gordon, thank you so much for joining us today for this. I guess it was a theme of data ops, and you've taken us through some very interesting concepts in the data engineering landscape. Massive thank you to Tony for hosting us this afternoon, and to each and every one of you that attended. Appreciate that you joined us. I think we had about 45 people on the call. Some have dropped off now, but we had a good turnout today.
Thank you, everyone.
Awesome. Thank you, Candice. Thank you, Gordon. Really, really great. Interesting to listen to. And thank you to all those who have attended. I see one of our board members and 2 or 3 of our chapter chairs were online from the Institute, so really good. But to everybody who's attended, a special someone from the Netherlands who knows who that person is, great to have you with us. And to everybody, thank you for joining us. The Institute appreciates your involvement. Gordon, your time, your preparation, your knowledge, really appreciated. Candice, as always, lovely to have you with us. Thank you for your time. And we wish everyone a great afternoon. Join us again soon. Take care, everyone.